So, of course, it's the 20th of October today. So we're doing modules 12 and 13. There's no activity for chapter 13. It's all conceptual. But of course, 12, there are some activities on the curriculum. So as you can see, there's 2 packet tracer ones there. I didn't really want to write my own troubleshooting one because, I don't know, me troubleshooting my own problems that I've put in sort of sounds a little trivial. But anyway, what I'm going to demo today is one from the old version of the curriculum. So it's actually here. And so we've got 3 routers. And of course, we've got the internet as well. And so we've got, I'm assuming, 3 different sites hooked together. One's got a server, the other one's just got normal hosts, and the other one's got a setup with Ether channel on it. So, yeah. Now, so basically, if we read the activity, uses a variety of technologies you have encountered during your CCNA studies, including port security, Ether channel, DHCP, NAT, P, and frame relay. Now, of course, frame relay isn't in version 7, it was in version 6, but I don't think we actually need to do anything with it anyway. So your task is to review the requirements, isolate and resolve any issues, and then document the steps that you took to verify the requirements. So this activity begins with a partial score already. So I've only just started it and I've already got 4%. So anyway. So as you can see, when it comes to DHCP, R1 as being a DHCP server for this network here. When it comes to switching, port security needs to be set on this switch for fast Ethernet 0/3. So we'll have a look at that. And link aggregation is for Ether channel between S's 2, 3, and 4. When it comes to routing, we're using Ospf with process ID 1. No routing updates should be sent across interfaces that do not have routers connected. So in other words, they want passive interface commands. And then there's NAT that is configured on R2, and no untranslated addresses are permitted to cross the internet. And so when it comes to WAN technologies, router 1 to 2 is supposed to be frame relay, but I haven't actually seen that. R2 to R3 is HDLC, which is actually the default encapsulation for serial links. And R1 to R3 is using P with PAP. Now, of course, point-to-point protocol and authentication is what that is. And so we'll do any troubleshooting that we required. So after we've checked that everything works, and so of course the addressing table should be consistent, and of course they should have full connectivity. And so we've of course got the addressing table there. So what I might do is just go through the list. R1. And so here, en show run. So R1 is supposed to be a DHCP server. And while we're looking at it, we can look at Ospf. So, too far? Too far. Here is our DHCP setup. And so IP DHCP pool access. We've got a network number of 192.168.10.0. Let's have a look at what R1 is supposed to have. Yeah, 10.1 is the router. Default net router of 192.168.1.1. Ooh, here's the problem. That router isn't on the same network as the subnet, so that's probably not going to work very well. So we need to modify that to 10. All right, so that's pretty much all I can see with DHCP having any problems. Now, with Ospf, we need to, what was it saying about Ospf? All routers process 1, cool. No running updates should be sent across interfaces that do not have routers connected. This one's got 3 links, 2 of them have routers, 1 does not. So G00 is the one we need, and that needs to have passive interface, and that's got that, so we don't need to do anything there. R2 was configured with the default route, but we're looking at R1 and we've got default information originate there. So that won't cause any harm because we don't have a default route on this router, but it is a bit of a waste of space. And so we'll look at that. Now, this isn't the first time I've done this, and so I actually have prepared earlier. So I've actually got the config that will fix that. So change the default router to 10.1 instead of 1.1, and I'll get rid of the no default information originate. So I'll just do that. Paste it in. No errors. Let's have a look at the score is now 14 instead of 4. So that's a positive sign. Now, as opposed to many other troubleshooting activities, this actually lets you check your scores. And so R1 is good. R2 and R3 have got Ospf problems. So we'll look into those shortly. All right. Now, oops, should have closed it, not minimized it. Now, R2, may as well go in numerical order. And show, oops, run. All right, now, I suppose what I could do, this has probably got the wrong details. It's got 1.1, so I'll just get this to do a new DHCP request, make sure that works, and that is better now. Sorry, change topic quickly. All right, so we're looking at R2 now. G00, G01. Now, G00 is a link to the rest of the world. Now, of course, we've got Ospf running, so G00 probably should have passive interface. G01 doesn't have a router, so that should have passive interface. So we'll look into that a bit later. Remember also this router has NAT on it, and so G00 is the IP NAT outside. Cool, that's right. All the other interfaces should be inside, and so the G is and the two serials are. So it's all looking good so far from what I've looked at. Now this router has a default route and out G00, that will work. It's a point-to-point link. Might have gotten an error when they put it in, but it's there, that's right. We probably could put in a passive interface command for G00 as well. I've got one for G01. I haven't actually got that in my config. But this is the router that needs to have the default information originate, and it doesn't. So they put it on R1, they didn't put it on R2. So that's a bit of a fault. So quickly, I'll just go down to here. Where's R2? So as you can see, I've got the default information originate there, and I've just added the G00 for passive interface. Now, let's have a look at NAT. So the interfaces are correct with the insides and outsides. Let's have a look at the NAT. So IP NAT inside source list NAT. So I need to find an access control list called NAT, and here it is. And so we're permitting all of the 10 network. So the 10 network is basically, I think, all the internal links around here. And so we're allowing all of that, and we're also allowing all of the 192.168s. And so I think that's what all these subnets are here, are all 192.168s. And so that seems pretty good, because if you remember the blurb, it actually said no untranslated addresses are permitted to cross the internet. So basically everything that comes out of here, all of the addressing, I suppose we could look at the addressing table. It's either 192s on the LANs and 10 on the routers. So that's all cool. So that looks like it will work nicely. About all we've got to fix is the router Ospf. So let's get back to this. R2. I don't see any errors. Now our score is 19. I think it was 14 before. So let's check results. So R1 and R2 should be good now. So R3. So EN show run. Now Ospf, they've done something very strange here. They've done passive interface default. So what that means is all interfaces will be passive unless you tell it otherwise. Now, it only needs one passive interface, it's G01. So they've actually done this the least economical way, but anyway. So I might just have a look at the routing table. I'm assuming if all of the interfaces are passive, that it actually won't have received any Ospf routes. And they're all C's and L's, so no, it hasn't. So nothing would be able to route from this network or this host to anywhere else. So that's certainly something that's broken. I suppose we could have a look at the routing table on this. We haven't actually done it. Show IP route. And so it is learning Ospf, but it's only learning from S000 up this way. And so it's learnt the gateway of last resort from R2, so that fix we've done has worked. But yeah, there's no, I think from memory, this network here is 192.168.30. Yeah. So that is not in the routing table on R1. Yeah, 192.168.30 is not there. So it hasn't exchanged any routes yet. So what we need to do on this is to actually do no passive interface S000 and no passive interface S001. That will then make them not passive, and so they will actually form adjacencies and exchange routes. So I think that's all that I've got there. Yeah, so basically no passive interface for the two interfaces and away we'll roll. That should fix that. Let's see what the score is before I paste it in. So we're 19, we're now 25. So we're getting there, 25 out of 60. And we're getting messages about adjacency. So that's a good sign. So let's do show IP route now. And so we've learnt 10 from R2. We've learnt 20 from R1. We've also learnt the default route. So that's a much happier router now, a lot more useful. Let's do a quick check results. R3 is happy as well. All right, now we've done DHCP, we've done routing, we've looked at NAT, we haven't tested it yet, but we've looked at it. We've looked at the default route and we've looked at Ospf. So we haven't done the switching yet. Now port security is configured to only allow PC1 to access S1's fast Ethernet 0/3. All violations should disable the interface. Now, of course, when you've got port security, the default behaviour is to disable the interface. So all we need to do is, of course, make sure that port security is on for that. but we also want it to only know the IP address of PC1. So EN, let's do a show run. And now fast Ethernet 0/3 is a member of VLAN 10, but it doesn't have anything else included. So that's not much use. So what I did last time was I actually stole the config from here. So I don't have to type it all, because that one looks good. And so port security, of course, is turned on, and so that will actually do the violation of disable automatically, so that's good. Then we've got to learn the MAC address, and the easiest way to do that is use the MAC address sticky. And so, yes, as I said, I have done this before, this troubleshooting, and so that's what I've done there, and it did like it. So, whoops. So we just do switch port mode access, port security, turns it on, and then it configures it to use sticky. And as I said, the default behavior is the behavior that's required, so we don't actually need to do that, anything else. And so that, again, doesn't look like it's got any errors. The score is now 35 out of 60. Let's do a check results again. So S1 is now happy. Okay, so we've just got a couple of switches to go. So we've done, well, there are no errors on any of the routers. So to me, those are good. I'm going to say router 1 learnt routes from both routers. They're all exchanging routes on all their links. So to me, that seems like they're all up and running. I suppose I could do a, what the hell? As it's, that's it, learning about R3. So if we do show IP interface brief, that will show IP interface grief instead of brief, yeah. And so all the interfaces are up, they've all got addresses, and it's all very happy. So I can't actually see a problem with it. If we do a show run, the two serials, this one is running HDLC, because that's the default encapsulation for a serial interface. That seems to be working nicely. This one is the one that uses triple P. And so that's hence the encapsulation triple P. Triple P authentication PAP, which is password authentication process. And so those are the settings. And so the username is R1, the password is Cisco CCNA. And so for that to work, there would actually need to, why is it doing that? There needs to be a username here. Wrong link. It's this one, sorry, it's R3. So the config we looked at there should be a username R1 with Cisco CCNA as a password. So that's how the authentication worked. And so, of course, with this one, it's actually got a username of R3 and Cisco CCNA. And so on R1, sorry, we should be able to find that information as well. So we've got username R3. And so that's how they authenticated. They've gone both ways. I don't think that was part of the curriculum either, was it, Cisco? I mean, triple P. It might have been mentioned, but I don't think there was actually any labs on it. So that's something else that was from version 6. But anyway, so the WANs all seem to be working well. So switching, we've done the port security. So all we've got to look at now is the port channel here. Now, in show run. Now, and I might do show VLAN. So we have a VLAN 11 and a VLAN 30. but pretty much everything is a member of VLAN 1. But VLAN 30 is the interface for configuration. Got a default there. So we have 2 port channel interfaces created, port channel 1 and port channel 2. This is S3, so 1 and 2, cool, that's what it needed. And so the first 2 are port channel 1. That all looks good. This 3 and 4 are for port channel 2. That also looks good. The only question mark might be this. I think it might actually, because that's the one that's linked to the router, I think it might need to be a trunk port. So I think that's pretty much all that needs to be done there. Yeah. That should be enough to fix it. Now, on S4, and show VLAN. Oops. Password for some reason. Show run. Now I think basically the only problem here is I think that the interfaces here are members of the wrong port channel. So this is group 3 when it should be group 2. And these are group 2 when they should be group 3. Now, in reality, you can see the status and it's all working nicely. But yeah, but I think that's enough of the score to be off. So yeah, what did I do? Yeah, so I've just swapped it around. The first 2 ports are on channel 2 and the second 2 ports are on channel 3. And I think that is enough to get it all working. What's our score? 40. Yeah, that's enough to get it 60. So yeah, not much has changed in that at all. If we fast forward, now what we might do was this seemed to be the most challenged host of all. It's got an IP address, cool. Let's ping from it to all the other hosts. So actually I might just use the addressing that's on the map. So ping, let's do 172.16.1.0, not 0, 10. 0 wouldn't have worked. So let's see if we can get to the external host. Okay, so that's working. Now what I might do is have a look at this and see how NAT is going. Show IP NAT trans. And so you can see that that was actually translated from its own internal address to an external address. And so that worked nicely. Now let's do ping, it's internal server 192.168.20.254. Let's see if that works. That's working nicely. What's this one's address? I'm not sure. 10.4. That's also working. Now, what I might do is I might actually do this command on the other host. Make sure we can get out through that way as well. So that's pinging the outside host, and that worked instantly. And so again, we can have a look at the show IPNet translations, and that's working very nicely. So 10.4 is getting out. So to me, that looks like pretty much everything is working. So that is our fault finding. Now, of course, normally when you start doing your troubleshooting, it's either you've noticed a problem with the network or a client has rung in and said there's a problem with the network. So you normally get a problem definition first before you start troubleshooting. While with this one, it was a little different in that you needed to check the requirements and to see how that worked. And so that's pretty much the only real difference between the two. And so, yeah, that did seem to work. Now, some of those problems were a little bit on the trivial side, and some were a little bit strange, but yeah. No. And so, yeah, that's just the way things are, I suppose. But yeah, like that channel group change I had to do made the score happy, but really didn't actually achieve anything, because even though that this was group 3 and that was group 2, that information actually isn't sent from switch to switch. It's just internally it can separate them. And so it was actually next to trivial. And so, yeah, when I first did it, I actually did show CDP neighbours, and that, of course, told me what switch was on which end. And so that was actually how I figured out where the channels were and what should have been what. And so, of course, that was how I figured out the 1 and 2 should have been channel group 2 and so on. So that's actually how I did it. So back to that network management is, yeah, CDP neighbour was useful for me. Got any questions on that process at all, or no? All right, so next week, of course, is chapter 14, which is, oh, what is it? Let's get the document up again. Network automation, of course. And so again, that's another conceptual topic. And so basically next week I will be demoing an example of the prac test that will happen the following week. So of course, yeah, next week is module 14, and the recap, of course, means I'll be doing a sample practical test to demo. I have already activated the module tests, like you asked. I've also activated the packet tracer tests that you can have a play with those. And I've also activated the practice theory test as well. That is active as well. So that gives you a little bit of scope for a bit of extra study. When it comes to chapters 12 and 13, I only put the videos up last night. I'm sorry, I sort of slipped my mind that I hadn't done those yet. So they are up now. So yeah, sorry about that they were a bit late. But anyway, I'll see you later.